Let's see if we can take a look at some conjectures and verify that they're true by using the law of detachment. So let's take a look and see. So in this first one, the following is given to be true. If M is the midpoint of a line segment, then M bisects the segment. And then we're also told that M is the midpoint of AB. And the question is it true? Can we prove the following conjecture that AM is congruent to MB? Well, a little picture here might be not a bad idea. So here's the line segment, AB, and M, we're told, is the midpoint. And then we also know that if M is the midpoint, then M bisects the segment. So M is the midpoint, therefore it bisects the segment. And so therefore we know that this length equals that length, and so therefore we know that in fact this segment is congruent to that segment. And so this is actually valid by the law of detachment, because what we see here is we have this conditional statement, and then we're told that the hypothesis is true. So this is in some sense as if we're saying if P then Q, and then we're told that P is true, and by the law of detachment that implies that Q is true. And so therefore the conclusion is that in fact we have two congruent pieces. Let's take a look at another example and see if we can verify a conjecture using the law of detachment. Here we go. So the statements that were given to be true are the following. If you are absent more than 2 times, then you will fail the class. And we're also told that Ed failed the class. The conjecture is Ed was absent more than 2 times. Can we use the law of detachment to actually prove the conjecture? Well, let's see. Remember, the law of detachment says that if P then Q, and you know that P is true, then you can conclude that Q is true. Now, is that logical template set up here? Well, here we have if P, that's if you're absent more than 2 times, so P is you're absent more than 2 times, then Q, you will fail the class. And we're told that Ed failed the class, so I'm told that Q is true. And I'm asked, Ed was absent more than twice. So this, in fact, is P. So I have if P, then Q, and I'm told that Q is true. Can I conclude that P is true using the law of detachment? The answer is no. The law of detachment says if P, then Q, and P is true, then Q is true. Here we're given a logical statement where we have if P then Q and Q is true. We can't conclude anything about P using the law of detachment. So here we cannot prove the conjecture using the law of detachment. Neat.